we have the little Sarah as well with us.
Yes, this is my daughter Ayat. She's 9 years old and she's going to help me.
Okay,
with
great, wonderful.
Because we are going to show some models and I've brought in some of the toys as well.
Wonderful. So thank you very much, Sarah, for doing this. I'm going to let one of the TAs introduce you formally, and then we can kick this off. So over to you, TAs, whoever has the intro.
Okay, assalamu alaikum everyone. I am Abdullah Salman, a teaching assistant here at STEMX, and it's an honor to introduce our 8th STEM superstar, Dr. Sarah Qureshi, who is the CEO and co-founder of Aero Engine Craft Private Limited, Pakistan's first commercial engine and aircraft research and development company that is developing environmentally safe, contrail-free aircraft engines for the global aviation industry. Dr. Sarah has a PhD degree in aerospace engineering from Cranfield University, United Kingdom, and her area of specialization is aerospace propulsion. Prior to this, she completed her master's degree in the field of aerospace dynamics from Cranfield University, working on the design of a trajectory following autopilot for the mid-air refueling of drones. She has recently co-invented and patented a supersonic commercial aircraft engine. In addition, she serves in the capacity of a visiting academic at the School of Aerospace at Cranfield University, an expert at Solar Impulse Foundation, and a member of World Alliance for Efficient Solutions. Dr. Sarah holds a private pilot's license and has also learned acrobatic flying while at Cranfield. She is a prominent voice on sustainable aviation in the media. She is considered to be a trailblazer for women in STEM and an inspiration for women leaders in aerospace around the globe. She was also awarded the Distinguished Aerospace Alumni Award by Cranfield University in 2020 for her leadership role and dynamic professional contributions to her field. The title for her talk is How to Build Flying Machines from Theory to Practice. So welcome, Dr. Qureshi. It's really inspirational. I mean, I'm tired just talking about your achievements. So over to you.
Bismillahirrahmanirrahim. Assalamu alaikum. Thank you very much for a very kind introduction. I would like this session to be interactive, and we are going to attempt that on Zoom. It's not very easy because I believe that the kids have already had one theoretical lecture on the theory of flight. So this one is going to be a bit practical, and then your assignment would be to build a plane, okay? So I'm not going to share any presentation. I just want all of you to have a pencil and a paper with you to take some notes or write down some points that would be useful later for you when you start making your plane. Okay. Can everybody hear me well?
Yes, your voice is clear.
Okay, and I hope that the students can reply if I ask the question.
They can raise their hands and we'll unmute them.
Okay, yeah, they can raise their hands or they can just reply. Okay, so I would start with one question. How many of you have been in a plane? How many of you have traveled in a plane? So you can raise your hands or you can, okay, I see a message. You can type as well. I just see one message. 2, quickly. Okay, so lots of children, I hope. Okay, so now one by one, just tell me what is your favorite part of that travel? When you experience traveling inside a plane, what is the best part? You can tell what is the best part, except the food. Yeah. Lift off, good. Okay, I see one answer. The view. Ayat can also tell me. Ayat, batao.
The
iPad. Ayat is saying iPad. Landing. Okay. Ending of the flight. Okay. Landing. Okay. When planes take off. Okay. My favorite part is clouds. Okay. All right. Somebody said about food. So people have different ideas, and it seems that everybody loves to fly and see the clouds and be in the air. My favorite part basically is the revving up engine. You know, when you are on the ground and you put your engine to full throttle, and then you know, you let the airplane roll. So it's rolling very, very fast to take off. And when it's in contact with the ground, you can really feel the speed of the plane and, you know, the sound of the engine. That's my favorite part. And you know, until it lifts off. So lift off basically. Anyways, I've also been flying, so lift off is a very elevating feeling, you know, when you're on the ground and all of a sudden you are in the air. Okay, so the first thing, does everybody have their pens and paper and pencil with them? Pen and paper or whatever? I hope everybody has that. Yes, no? You can also just unmute your mic and talk to me if it takes time to type. Okay. आप
Kids,
मुंह
I
से भी
allowed
बोल सकते हैं,
everyone to
मुझे
unmute
बताओगे?
themselves.
जी,
So if
इनको unmute कर दें for the time being,
yes,
ताकि
they
ये
have the
मेरे से
option.
बात करें.
Yes, ma'am.
ठीक है? जी, okay, good. Everybody should have one. Okay, now the first thing I want to tell you is that you must remember that a good flying machine is able to fly on its own without a powered engine. ठीक है? जब आप जो जहाज होता है ना, that is basically flying on the science of air and on the laws of physics. वो उसके ऊपर उड़ता है, वो engine के ऊपर नहीं उड़ता, and that is real flight. Okay, when you put an engine to it, then it becomes a machine. Then it's not a plane, it's a machine. Okay, so the best way to learn flying is gliding, paragliding, sailplanes, because that's when you are actually flying. You know, with gliders like wings, you are actually flying. When you are in a powered flight, you are inside a machine. Okay, so that's one thing. Okay, now I'm sure all of us have made paper planes. Yes, no?
Yes, ma'am.
Ma'am.
Yes, okay. Okay, so tell me one thing. If anybody has the answer, you can tell me. Why is the nose pointed? Why do you make a pointed nose on the plane? Why not a blunt nose? To cut through air, good.
So it could travel
Yes,
further.
Ma'am,
good
for
answer.
friction. So that there'll be less air resistance and
Okay,
you can
good.
easily go through the air.
Yes, true.
To give it an
Yeah.
aerodynamic.
So because for, you know, we want to have a good aerodynamic profile. We want, because you see, as I said, the answer lies in my previous statement. We say that aeroplanes fly on the science of air. So we have to optimize the behavior of the air. That is our focus. Okay. So yes, we want a very aerodynamic profile, so that you know, the air flows over the plane in a very smooth way. There's no resistance and there's no drag. In aviation terms, resistance is called drag, right? So we don't want any drag. So that's why we make the nose pointed. Okay. And why do we make the nose heavy? जो जहाज बनाते हैं, आपको याद होगा, मैं इसकी कागज का अगर बनाऊं, तो this part is basically double. You see this one? Now this is double. Yeah, there's more double paper here, and then you fold it, right? And you make the wings here. So this is single paper, right? Okay, so why is this part double? Why is this heavy? Why do you make it heavy? Just because you're making it out of a square paper, or there is any other reason? किसी के पास जवाब है तो आप बोल सकते हैं.
Excuse me, ma'am. Ma'am, so it could be stable.
जी.
So it could fly like in a stable way.
Yes, that's right. We want flight stability, because I'll tell you now, we'll talk about the forces acting on the plane and how does that help in flight. How does it help in flight stability? या आपने ये तो सारे लोग बता रहे हैं कि स्टेबल हो जाता है, ये तो शायद आपने देखा भी है कि जब आप जहाज पर से उड़ाते हैं वो स्टेबल होता है, लेकिन क्यों? एक बच्चे ने लिखा है ग्रेविटेशनल,
Because it's balanced weight.
because we want
it has
the
a
nose
balanced weight.
balanced weight, and we want the nose to be heavier. We want all the weight to be on the nose. ठीक है. और कई दफा हम ये भी कर सकते हैं, आपने एक ट्रिक ये होती है कि आप जो उसकी नोज है ना, उसके ऊपर आप एक पेपर क्लिप लगा दें यहाँ पे ऐसे करके. ठीक है. अगर तो हम उसका बनाते हैं, कार्डबोर्ड का बनाते हैं, तो we keep a slot here and we put in a coin to make the nose heavy, but that's for heavier planes. But for light paper planes, just put a paper clip here. Try it after the class, okay? Make a plane and keep. And the other people, what they do is they make a double fold here, 2 fold. That's also one design. That's another design. So that makes it even heavier. So you can use both. You can either make a double one with 2 folds here, or you make a paper clip one. Okay. Okay. Now we will talk about the forces acting on the plane. Acha, first of all, tell me what force is acting on you right now. अभी आप सब बैठे हुए मेरे से बात कर रहे हैं या लेक्चर सुन रहे हैं, आप पे इस वक्त कौन सी फोर्स एक्ट कर रही है?
Gravitational force.
Gravitational force or weight. Weight is because of the gravitation. The force is gravity and weight is because of, we have weight because of that. ठीक है. Okay. Okay, but for an airplane which is static, is on the ground, what force is acting on it? If it's sitting on the ground, gravity, right? Okay. Acha, but when it's in the air, there are 4 forces acting on it. आपने पिछले लेसन में किया है कि वो 4 forces क्या होती हैं? Yes or no? No? Okay. The 4 forces acting on a plane are thrust, lift, gravity and drag. Lift, drag, weight आपने लिखा है और air resistance. I won't say weight is not आप thrust, lift, gravity, drag. Air resistance जो है ना, आप उसको अब aviation की जुबान में कहते हैं drag. तो use आए किसमें propeller होगा. अच्छा. Okay. So I'll discuss them one by one. What is thrust? How do you get thrust? Thrust is
Speed of the
something,
object.
is a force, right? Thrust is a force. How do you get, what are the different ways of getting that thrust? From the engines. Engines is one way. There's another way as well. For small planes. For the plane that you make at home and you fly, how do you give it thrust? How do you give thrust? का मतलब क्या है?
Force.
जी बताएं, सॉरी कॉल आ गई थी. फोर्स कैसे देते हैं? Yes, force from your hand as you are flying it, you see, or a catapult. You know what a catapult launch is? जिसको हम उर्दू में वलेल भी कहते हैं. It's like a rubber band. Yes, that's a propeller. आयुब को मेरे उसमें ना जितना बैग है उसमें को catapult पड़ा. First में बैग है. Okay. So, right. So that's for small planes, we have the force of our hands or force through a rubber band. We use a catapult. Okay. For big planes, we have engines. Now engines come, there are two, do you know what the two type of engines are there in the plane?
Propulsion and jet engines.
Yes, one is piston engine and one is jet engine. In the cars, there's only one type of engine, which is the piston engine. If you talk about engines, now we have battery powered cars as well, but that's a different thing. But in aircraft, we use both. Initially, when aircraft were designed, they started using the same engines that were used for cars. So they started with the piston engine. But the piston engine has its limits of efficiency in the air and of weight. So if they had to fly higher, they then went for gas turbine engines or the jet engines. So what the piston engine does is that we use piston engines for low altitude and for low speed and low noise aircraft. And the piston engine is usually coupled to a propeller. ये जो propeller है ना, ये भी एक तरह का wing होता है, ठीक है? It's designed like a wing that creates lift. But the only thing is that the propeller creates lift not in the upward direction. In a helicopter, it creates lift in a direction that lifts the plane, okay, and the helicopter. But in a propeller, it creates lift towards the plane, in the sense that that we have the Newton's law that for equal and opposite reactions. So the airflow is this way that propels the plane ahead. It pushes the air backwards, right? So this is what we have as a propeller. So then and piston engines only work with propellers. Now gas turbine engines or jet engines there are three different kinds. One is the propeller, again, that you couple a jet engine with the propeller, okay? The other is that you generate thrust out of a nozzle, like the hot exhaust gases of the engine, of the combustion of the engine, exit from the back of the engine at a very high speed, and that the opposite reaction propels the aircraft forward. That's a jet engine. Okay. Now, and the third kind is like what you have traveled in, that's the turbofan engine. The turbofan engine is basically a jet engine, but it is ducted. It comes within a duct which has another fan. So there are two or three, there's one compressor, but there's also another big fan in front that you must have seen when you see the engine, right? And that basically is also for suppressing noise and also for creating thrust by just compressing air. There's no combustion going on. We'll have a separate session on jet engines, and then we can discuss it again. But I'm just giving you an idea, because when you talk about engines, you have turbofans, turboprops, and turbojets. So you should know the difference. And then you have piston props as well. Now, the issue with all kind of gas turbine engines like turbofans, turboprops, turbojets are usually that they are effective or efficient at high altitude and high speed. Okay. Turbojets make a lot of noise, like you've seen the Air Force planes. Turboprops are medium altitude, and turbofans are low noise. They are the commercial planes that we fly in, that see on airports, that they are used for passenger and flights and transport, okay, because we don't want that kind of noise all the time. Okay, so now that's thrust. Now we talk about lift. अब आपको पता है कि लिफ्ट का क्या फॉर्मूला होता है? पिछली क्लास में किया आपने? Yes or no?
No.
I don't see any answers. No? Okay. Lift is L, you can write down half of or 0.5 into CL into Rho is basically density of air.
Excuse me, ma'am. I'm so sorry to interrupt. Can you please repeat the formula?
अच्छा आप यूं करना कि आप ये इंटरनेट से just see the formula for lift and drag, but I just what I want to explain here is basically lift is proportional to your density of air, your speed, and square of your speed and your surface area. Okay. अगर आपने किसी चीज से लिफ्ट हमने क्या करना है हम जब अपना प्लेन just think about your plane, don't think about anything else. Okay, I want you to imagine your plane that you are going to build. Now what do you want that plane to do? What do you want that plane to do when you make a plane? You want it to fly. So how do you want it to fly? We are not putting any powered thing, no batteries, no drones. I am very against drones. जो बच्चे बाजार से जाके वो motors वाली मशीनें उठा लाते हैं and they say we are flying. That's not flying. Okay, so that's not where you start with. You need to start with proper. You need to understand how to build a plane. Okay, so इसके बाद before I forget, just make a note. There's a shop called Hobby Lobby. Okay, they have some small kits, assembly kits of light balsa wood because we want aeroplanes to be very lightweight for them to fly. Okay, and so they have some kits that you can assemble and you can fly with the catapult. They're not very expensive, within 1,000 rupees or 1,000 rupees. That's something you should buy and try to fly it, even if you want to give it as a present to your friend on the birthday party. It's a very good gift and it has all its instructions written. Like we have some, I'll show you जो हमारे पास models वहाँ से आए हैं, ठीक है? Now let's talk about are you all imagining the plane that you're gonna build? Yes or no? Yes? Just one person?
Yes,
दो yes, तीन yes आए. Okay. Okay. तो आपने उसको किस चीज से उड़ाना है सबसे पहले? Lift. You have to generate lift, right? Now, how are you gonna generate lift? How are you gonna generate lift?
Ma'am, by starting the engine.
There's no engine, no propeller, no engine. That's what I said. We are making, ये बात मैंने सबसे पहले की थी कि forget the engine. Forget the engine. Airplanes don't fly because of engines. They fly because of the aerodynamics. They fly because of the laws of physics and because of the science of air. Okay. So how do we generate lift? Now, मैंने आपको बताया कि lift is proportional to the speed, square of the speed, the density of air, and the surface area. अच्छा, surface area आप कहाँ से provide करेंगे? प्लेन बनाएंगे उसको surface area कैसे मिलेगा? Area wings से, good. ठीक है? That's what wings are for. The wings are there to generate lift. They give you the surface area. So if your lift is proportional or directly proportional to the surface area, that means your wing has to have a large surface area, right? Either it has to be very long or it has to be broad or a combination of two, but you need a large surface area in proportion to your plane, right? That's the first thing. The second thing it's proportional to is the square of the velocity. तो velocity आप ज्यादा कैसे दे सकते हैं उसको?
By pushing it.
Yeah, by pushing it is one thing. The other thing is that this is the basically the also the you are pushing it against air, so it's also the velocity of the headwind or the air that is in front, the opposing air. तो इसका एक तरीका तो होता है कि आप उसको पंखे के सामने रख दें, तो एयर वेलोसिटी ज्यादा है ना वहां पे, ठीक है, right? So because you see, jitna aapko, let's suppose if this is the wing, I'm assuming this is the wing, okay? So the more air you comes in here, and the speed of the air, the faster the air here is, the more lift will be generated. Oops, I lost the screen. Okay. The more air that comes and hits it here, the more lift will be generated. So if I put this, now this is just at whatever, you know, in a room. But if I take it, if there's a pedestal fan here, it would lift off. Even if अगर आप अपना हाथ भी ऐसे करके रखते हैं ना, और आप देखें कि पंखा आपके सामने है, तो आपको एक force अपने हाथ पे feel होगी, because what happens is that the air hits here. It has to be at an angle. If it's streamlined, then there's equal air here and here, so it won't happen. But if it's at an angle, there's more air that hits here, and there is a vacuum on this side. So your hand lifts off, okay? Try this in front of a pedestal fan. Or even when you're going in the car, थोड़ा सा हाथ बाहर निकालें टेढ़ा करके, तो you will see the force on your hand, right? So for lift, you need more force, and that's one way is that you you provide a headwind somehow, which is not very practical with hand held planes, but it's still that's something you should know, right? Or you give it speed by throwing it very fast, because when you throw it fast, you're giving it a very high initial velocity, right? So the square of that velocity will also generate lift. Or you catapult launch it with a rubber band. So with the rubber band, it's easier to transfer all your energy, because the rubber band itself stores it as potential energy, right? So you are launching it with a lot of energy, and that is translated into velocity. Okay, so there's velocity, there's surface area, and then there's air density. Right, jitna air jo hogi, the more denser the air is, more lift will be generated, right? So with planes, like on ground, there's more lift generated on ground because the air is denser. It is at 1 atmosphere pressure, and they take off, and at takeoff you need the maximum lift. But once they are flying, then as you go up and up in the sky at around 10,000 meters or 36,000 feet, where your normal planes fly, where you see those clouds that you were talking about, your pressure is 1/4, reduced to 1/4 of an atmosphere. So your lift also reduces because of that. Okay, so we are just talking about our own plane, right? So on the ground, it's not very easy to change the air density. Again, one of the things is that आप उसको पंखे के सामने, pedestal fan के सामने try करें, जहाँ पे आपको बहुत तेजी से हवा मिल रही है, या अगर बाहर एक डायरेक्शन में हवा चल रही है, तो उसके अगेंस्ट उसको फ्लाई करने की कोशिश करें, ठीक है? Okay. Now, this is the second force. What's the third force on the plane is basically gravity. Gravity की हमने बात कर ली थी. Gravity is just, it's a function of the mass. Your mass into gravity gives you a force, which is your weight that pulls you down. It always acts in the downward direction. And we say that some people say that gravity is an aviation engineer's worst enemy, because whenever you design a plane, you have to design it against gravity, because you want it to fly, you want it to lift off against gravity, right? And you have to create enough lift that it can defy that gravity, or it overcomes that gravity. Okay. So next force is drag. Now again, drag is very similar to, look into the formula for drag as well. You can Google this. Again, it's proportional to the density of air, the square of the velocity, and the surface area. So what happens is that although, when you are, because the air is is on the opposite side of the plane, you get more lift, but you also get more resistance. You get more air friction, right? Which is drag, and that although you're increasing lift, but you're also increasing drag. And drag is very important because when you have to land, you have to slow down the plane. Then what is the factor that will slow down the plane? It's the resistance, it's the drag, right? So for that we have, there's an optimum L over D ratio, lift over drag ratio. Always remember that engineering design is not magic. It is always a compromise. It is a trade-off. You improve one thing, the other thing goes down. But you have to find some middle grounds that you get, a bit of an advantage on this side and a bit of an advantage on that side. So experimentally, what they've done is that if you keep the angle of attack around 11 degrees. Now, again, this is a very valid point when you're designing your plane. आपका जो अगर आपका ये fuselage है, let's suppose, तो आपका जो wing होगा, इसका wing, एक मिनट, आपने इसका जो wing लगाना है ना, उसका जो angle होना है ना, it's not gonna be straight. It's not 90 degrees to the air. The angle that your wing should make with the fuselage, with the air is 11 degrees. Okay. So if you make a cardboard plane, take a protractor and mark 11 degrees, and that's where you make a slot and insert the wing inside. Okay. It should not be straight. That's the optimum L over D ratio. So keep that in mind. जब आप अपना प्लेन बनाएंगे, ठीक है? Okay. Now, now what we need to do is, give me 2 minutes. We've had an electricity shutdown. Let me put the phone on the UPS. Okay. So I'm gonna shut down my camera. Just Google the formula for lift and drag and type it in the message box. Okay. Yes, no.
Okay, ma'am.
Okay, ma'am.
Okay.
Okay, ma'am.
Okay. Okay. Give me 2 minutes.
Okay, ma'am.
Yes, there's some answers in the chat box.
Okay, let me see. किसी ने टाइप किया chat में? Okay. Okay, the electricity is back. I'm just trying to look at the chat. I don't know, मुझे चार्ट ही नहीं मिल रही. Okay,
Yeah.
CL 2 V 2 by 2. Okay, so 2 by 2 is 0.5. And have you noticed something that I haven't told you? That's part of the formula. We talked about V, we talked about drag coefficient. Okay,
Ma'am, we didn't talk about C.
C. Okay, what is C?
Ma'am, drag
What did
coefficient.
you actually मुझे ना आप लोगों की चार्ट नजर नहीं आ रही for some reason. मुझे नहीं पता ये आ गई है.
MC is the wing shape.
Okay. आपने there might be different notations. Half, rho, V square, C, D, A. A is for area. Sometimes some people use S, some use A. Okay.
M.
Drag coefficient and lift coefficient. Now what are these? ये क्या चीजें हैं? Okay. हमने basically these are dimensionless parameters. क्योंकि जब हम किसी चीज का lift या drag coefficient निकालते हैं ना, lift या drag निकालते हैं, उसका एक proportion निकालते हैं, तो it is also dependent on the geometry of the design, right? There are many factors because these are all what we've talked about is all aerodynamics, right? We talk about, okay, one part of the design is the area of the wing, but also the shape of the wing, right? The aerodynamic profile of the wing and the shape of the aircraft, how much resistance different aircrafts would give because they have different frontal areas, they will give a different resistance. And then the speed of the speed, we've talked about speed. So these the drag coefficient and lift coefficient basically are there to you know, they're basically dependent on the geometry that we are using. Because अब आप जब मैं आपको कहूंगी कि आप planes बनाएं, आप different materials use करेंगे. Some of you might use cardboard, some of you might use balsa wood. Even if you're using cardboard, you might be somebody is gonna use a coarse cardboard, somebody will use a you know, a very shiny one. So the air will flow differently. So behavior of air would change. So this coefficient of lift and drag basically accommodates what for these changes, right? So that's why, and one of the good thing is that for every design, every shape that you make, the coefficient of lift and the coefficient of drag is defined. And that coefficient of lift is only dependent on the shape of the profile. Now, what advantage it does not have to do anything with the size of the aircraft or the wing or the aerodynamic shape of the wing, right? So उससे हमें क्या advantage मिलता है? What is the advantage that we get here? No
We can
advantage.
make aircraft of our own shapes and sizes.
मुझे आपकी आवाज नहीं आ रही सही.
Then we will be able to make aircraft of our own of our own design and shape.
Okay, maybe I didn't quite get what you were saying, but the advantage is that you see these aerodynamic parameters like coefficient of lift and coefficient of drag is the same for the same shape but different size. उसका ये फायदा होता है कि आप एक small scale पे एक aircraft बना लें और उसको आप wind tunnel में test कर सकते हैं. और जैसे मैं आपको कह रही हूँ कि आप अपना एक plane बना लें, right? You make a small plane, you fly it, you test it. Now, the behavior would be the same if you scale it up. Even if you make the same shape as a passenger plane, it would have the same behavior. That's the advantage, that you can make it on a small scale and you can test it. यूजली हम जब टेस्ट करते हैं ना तो एक विंड टनल होती है, एक बॉक्स होता है, उसके सामने एक फैन लगा होता है, वहां से बहुत तेज हवा आ रही होती है, इस साइड पे हम अपना रख देते हैं एक क्लोज बॉक्स के एक साइड पे. यू कैन आल्सो मेक योर ओन विंड टनल. टेक अ स्क्वायर long square cardboard, put a pedestal fan on one side, a small one, and make a small glass window. एक विंडो बनाए, उसके अंदर उसके ऊपर एक आप ट्रांसपेरेंट सी वो लगा लें, पॉलिथीन या वो जो स्लाइड की शीट्स होती है ना, transparent one, so that you can see. And then you put your plane inside it, right? And then you'll see how your plane will fly, right? That's called a wind tunnel. Okay. So that's how they design planes, because every time they can't make huge planes and then they test it, and what if the plane doesn't fly? Then it's a waste. Or what if the plane flies and it crashes because you didn't work out the lift properly or all the aerodynamic parameters properly? So the best thing to do is that to make a scaled down small model, you test it basically, and you test that model, and then you make a bigger plane. Okay, अभी मुझे कोई पूछ रहा है कि हमने project submit, this is not your exam. I'm not here to take some exam or promote you. I'm just trying to teach you how to make a plane, and I would expect you to focus on that. Okay, आपने एक जहाज बनाना है, आप सीख लेंगे, आपका फायदा, आप नहीं सीखेंगे, आपका नुकसान है. आप इस वक्त इस प्रोजेक्ट्स और सबमिशंस की बात इस वक्त ना करें. Just focus on how to make it plane. So the first thing we've done is that you need to make the wing wide, right? And we know जो हमने पहले किया था कि we have to keep the nose heavy, and one of the ways to keep the nose heavy is that put a paper clip or make a slit and put in a coin, right? So that's the important parameter. Okay, then do you know the 6 degrees of freedom? 6 degrees of, what are the 6 degrees of freedom in a plane? No? Okay. Let's suppose can you see this model? Plane ka, maybe I should turn off the light.
Yes, ma'am.
This model hai, theek hai? Okay, this is the plane. Now the plane can do, there are ek to ye hai ki the plane can go up. Okay, this is called pitch. It can turn, this is roll, and it can move sideways. This is yaw, pitch, and roll. These are the three movements or the 3 control surfaces of the plane, right? Yes, agreed. And we have one more, which is called heave, which is usually in rotorcraft, that they can take off vertically upwards. That's called heave, but that's not for fixed wing aircraft. Okay. So now we have to, when we talk about these are called the control surfaces of the plane that create these movements. जो अभी हम बड़े मॉडल के ऊपर भी जाएंगे, how we achieve yaw, pitch, and roll, and basically we do that through rudder, elevator, and aileron. I will take you to the model now. And one of the things I want to tell you is that do you know about, have you seen this? This is a police car. अगर आपने इस सही वाली, this is my daughter's toy. इसके आपने देखा है कि ये 2 लाइट्स होती हैं, एक रेड होती है और एक ब्लू होती है. Yes or no? Have you seen this police
Yes.
car with? What is that red and blue light called, and what is it for? Because we have that on the plane as well. Have you seen the plane at night and you see a red light on one side and a blue light on the other side? No, it's not the siren.
Miss Siren?
siren to hota hai, but siren can be any color. Why is half of it red and half of it blue? And even in a plane, when you see it at
Miss, is
night,
it because to
night
show
has
that
a
this is
blue
for
light.
police? That there's emergency?
Ma'am, so that other planes in the sky know that there is a plane coming towards them.
Okay, that's fine. You see a plane coming. Okay, now what happens is that there is a red light on the left, and police की गाड़ियों को ना देखें उन्होंने कभी उल्टी लगाई होती हैं, but red light is on the left and blue light is on the right. Red is called port and blue is called starboard. This is a notation they take from ships. Okay. Now the benefit is that for very fast moving objects like planes or very far off objects, if you see, if it's, you can see, अगर आपकी तरफ से देखूं या आपकी तरफ आ रही है, so you see, if I look at
Yes,
from,
ma'am. Yes, ma'am.
yes, now Ayaz is holding the camera. I thought we showed it. Okay. Now this is the plane, and this is the propeller of the plane that we just talked about. This is the engine. Again, why have they put the engine here? Yes? You don't know?
So that there's more weight to move the propeller.
Yes, to move the propeller, and also it can move to a star, but you need to keep it heavy. Okay? So that it's heavy, right? We want the nose heavy. Then we have the, okay, now this is the wing. It's a very big wing. And then we have the, we have the control surface here for roll, to turn the plane. The aileron is here to turn the plane. Then we have the tail and the fin. Okay, this is the fin, this is the rudder. This is for the yaw. And this is for the pitch up and the pitch down. Okay, so it's not a very efficient way of showing you, but probably in a live session it would have been much easier. Okay. All right. So let's continue. I wasn't really able to show you what I really wanted to show you, but anyways, so we basically have the control surfaces of the plane, but in the plane that we are going to build, we will just have the wing. We would not be, because for planes that have the control surfaces, you need an operator for the control surfaces as well. So the pilot has to be there inside the plane, or you have to operate it remotely with a remote control, right? So, but you're not going to do that. You will make a simple plane that can fly. And then there are some, do you know about, okay, there are some things that make the plane stable. If you notice that this plane was a high, there are some planes which have the fuselage. First of all, if we talk about the fuselage, it's a monocoque structure. This is the way a fuselage is. It's like a ribbed structure, right? To give it strength. And on top of it, you have a light sheet like aluminum to cover it. So this is the fuselage. Now then you have different kind. You have a high wing plane where your wing is basically above the fuselage. See, your fuselage is here and your wing is here. This is a high wing configuration. What do you think is the advantage of the high wing configuration? Anybody? Do you think it is useful to have the wing on top of the fuselage or below the fuselage?
Ma'am, I have a guess.
Yes, go ahead.
Ma'am, we may be able to generate more lift.
No, it has lift is by the wing. So the wing is here. The wing will generate the lift. But
And
you
below.
see below. Okay. There are both ways are possible. They both have their own advantage. When you have the wing above and the fuselage below, we know that the fuselage is the more heavier part, right? So the heavier part has the center of gravity, so it always stays in this configuration. Okay, so it is very stable like this. जैसे जो मर्जी हो, ये उल्टा पुल्टा हो, ऐसे हो वैसे हो, कलाबाजी खाए, मगर ये फिर सीधा हो जाएगा. It is inherently stable because it will also, the heaviest part will point downwards, and fuselage is the heaviest part, wing is the lighter part, right? But in acrobatic planes or military planes, which have to do maneuvers, fly upside down and all that, they have a low wing configuration. Okay, because they don't want to be stable, they want to be inherently unstable, and they want to fly this way and they also want to fly upside down. So they have a uniform profile and they will have a low wing configuration, right? And the low wing configuration is also more efficient. In commercial aircraft also we have a low wing configuration. And then so this is about stability. Then the other thing we have for stability is that if you have noticed, there is, the wing is not straight, it's at an angle. First of all, there's an angle like this, which is the angle of attack, which I told you should be 11 degrees. Then we have an angle which is like this. This is called the wing dihedral. Okay, this is around 3 or 4 degrees. अगर आप देखें जहाज सामने से आ रहा हो तो वो उसका विंग बिल्कुल स्ट्रेट नहीं होता, थोड़ा सा ऐसे आपको एक ट्रायंगल सा नजर आता है दो विंग्स के दरमियान. And this is basically for your stability, sorry, roll stability. उसका ये फायदा होता है कि if your wing turns on this side, you know, there's unequal pressure on both sides, so the wing straight inherently becomes straight. If it rolls to the other side, there's less lift on one, more lift on this wing is raised, so there's more lift here, so it becomes straight because there's pressure from the top, right? And then we also have what we call is a swept wing. Swept wing is के आपका wing सीधा नहीं होता, ये थोड़ा सा इस तरह भी angle होता है, like this, right? There's an angle, and that angle is basically for your stability, that if the plane turns like this, there would be more pressure on the outer wing, more force, and it would straighten the wing. So these are the three things that you need to look in a wing when you make your plane, that it has to, you need to give it an angle of attack, you need to give it a dihedral, and you need to give it a sweep. Okay, and you have to keep it nose heavy for stability. Okay, and okay, I've told you most. Now I'm gonna tell you about two different. Can you tell me the difference between, these are very small models, but can you see this model?
Yes, ma'am.
Yes.
can see it.
Okay. And this one?
Yes, ma'am.
Do you recognize which
ma'am.
plane this is? This one?
Ma'am, it is a passenger plane.
Public plane.
Airplane.
Yes, commercial plane. Okay. And this one?
The
Ma'am,
fighter
it's
jet.
fighter plane.
Ma'am, fighter.
Okay.
Ma'am, it's fighter
Um,
plane.
What is the difference?
Ma'am, a fighter jet can only carry 1 or 2 passengers and has a
Yes.
very high
This is a supersonic wing. It's also, actually, this is a Concorde model. The Concorde was a commercial supersonic aircraft. So this is called a delta wing. And this is a subsonic wing. Subsonic is basically when the plane flies below the speed of sound, because you see sound is, no, this is not built with weapons. They are both passenger planes. Sound is a pressure wave. right? So when the air molecules, they move and they generate pressure, that's how sound travels. So sound has a speed in air. Okay, it is dependent on the temperature of the air and the properties of air, right? So what happens is that if you try to move faster than the speed of sound, you tend to compress the air and it creates like a sonic boom. Have you heard some military planes take off? Or sometimes
Yes,
they
ma'am.
they do their exercises and you hear sonic booms. So that's what happens. So those planes have a supersonic planes have a delta kind of a wing, okay? And the normal planes have a this kind of a wing. Now this is a swept wing, right? अभी जो मैंने आपको बताया ना कि इसका इधर भी एक एंगल होता है, और अगर आप ऐसे देखें, इसने मॉडल में इतना नहीं बनाया हुआ, बट इस साइड पे भी एक एंगल होता है विंग डायरेक्शनल। और किसी ने मुझसे पूछा कि वो, आई थिंक ही वाज आस्किंग अबाउट द विंगलेट्स हेयर। winglets होते हैं because you see there is a air, you have a flow of air on the plane, but at the end the flow has to finish, so it creates like a round vortex. So avoiding that vortex, you create a winglet. That is very common in all the planes. I don't think I have it in a model, but it's something you see everywhere. So this is okay. So now can you tell me how you're gonna make your plane? Can anybody tell me? Are you gonna use cardboard or balsa? Balsa wood is like this very thin board, but it's not very
I'll
easily
use
available.
balsa.
Do you have balsa? Otherwise, you can use cardboard.
Ma'am, I'll try to make both of them.
Okay.
Ma'am, I will make
तो
cardboard.
सबसे पहले आप क्या करेंगे? You design the wing first, okay? Right? You work on the wing. Yes?
Yes,
And
ma'am. Yes, ma'am.
we've talked about, you need to give it an angle of attack with the fuselage, when you fit it on the fuselage, you have to give it a bit of a sweep and a bit of a dihedral. Then you make make a slit in the fuselage on the nose and insert a point, right? And at the back, you have the tail. Okay. And I wasn't able to show you the control surfaces very clearly, but if you can maybe make slits in the cardboard to make the control surfaces. Okay. अच्छा, अब I think ये इसके लिए तो हमने काफी पढ़ लिया है, और अब बन जाएगा जहाज सबसे.
Yes, ma'am.
Yes.
And does anybody want to make a supersonic one, or do you all want to make the normal one?
I think supersonic would be more interesting.
Supersonic, okay, you can try. That would be interesting. Okay.
Supersonic.
अच्छा, अब मुझे बताएं कि अब कोई सवाल हैं, because if not, then we can talk about a bit about engine. But I think I'm done. If you have any questions, how long is this session for? How much time do we have?
So,
Around 10
so
minutes,
Sarah, it
ma'am.
runs till about 7:30 or
9
so.
minutes.
We
You
have
have about 10-15 minutes.
10-15 minutes. Do the kids have some questions? No questions?
We have a question. Somebody sent it to me in the chat. How do we measure the angle of attack?
Angle of attack is, as I said, कि आमतौर पे जो optimum angle of attack is 11 degrees. Okay, so angle of attack is basically the angle that the wing makes with the direction of the air, because sometimes the direction of the air is not straight, but for simple cases we assume that the direction of the air is straight and it is aligned. So you just have to make a straight line through your fuselage and make an angle of 11 degrees and keep a cut at 11. Make a slit in the fuselage and insert your wing, an angled slit. Okay.
Ma'am, I have a question.
So this is how they've measured it is basically they've done experimentation. They do different, they make the wing and they test it in the wind tunnel at different angles, and then they figure out how that is going to, where are they getting the best lift. So when they know that, okay, at 11 degrees, the best lift was achieved, and that's where they fit it. That's how they figured it out. Experiment.
Qasim Dawood has a question. You can unmute and ask Qasim.
You mentioned that the winglets at the end of the wings are there to prevent vortex.
आप थोड़ा सा ऊंचा बोलेंगे, मुझे आपकी आवाज नहीं आ रही.
You mentioned that the winglets at the end of the wings are there to prevent vortexes from forming. But what does the vortex do? Like if a vortex were to form, how would that disrupt the flight?
Are you talking about wing vortices? I can't hear you very well.
You mentioned winglets at the end of the wings, right? To disrupt vortex,
Yeah.
stop vortexes from forming. So
vortex is basically, you see, the air is flowing over, right? Air is coming like this, going up and going in, up on top of the wing and below the plane. Okay, so it's just going streamline. Now where the wing is finished, it goes like this, and also on the side. So it starts. There is a difference in pressure on both sides of the wing. That's why the wing lifts off, because there's more air pressure here and less here. So the air from the side starts going like this. That's the vortex. So you put winglets to avoid that.
But so then the vortex, if there were a vortex, that would prevent lift?
Yes, it's like a turbulence. It's a disturbance.
Okay, I get it. Thank you.
You can look up wing vortices for some images on Google as well. It will help you understand. It would have been good if I had a blackboard, then I would have drawn it for you. Anything else? Okay, the propeller is again another wing. Propeller is just a wing, but it's sideways wing, right? Like your wing is basically, the lift is generated in a normal wing, lift is generated here. So the plane goes off like this. So the propeller is a sideways wing. So lift is generated on the side. So the propeller moves forward. Okay. Why does the winglet move when we? आपकी chat में एक सवाल आया.
I'll read it. Why does it move when we take off and land, but not when we are in the air?
The winglet moves. It's just, I think it's the velocity, the velocity that it's facing, and there's the wing also moves because there's a lot of load on the wing. It's fixed on one side and it's free on the other side. See, so sometimes there is a bit of a flex in the wing. So it depends on the forces that are acting at that time, and also the direction of the wind.
Right.
But I've never
talking about
observed because
yeah.
in order to observe that, you have to be sitting on the seat, which is just over the wing. Okay, buttons in the cockpit. Okay, yes, they're connected by hydraulics. You know, the control surfaces move by hydraulic, because for big planes, for small planes like the one I showed you, they just have a simple wire. So there's a motor that is attached that you move, and that moves a simple wire that moves the control surface. But in larger planes, it's connected by hydraulics. And there are redundant systems as well, like one control surface will maybe have 3 hydraulics. One of them is working, but 2 of them are backup hydraulics. Like if one system fails, you use the second one. If the second one fails, you use the third one. Okay. What are hydraulics? Hydraulics is when you use the compression of oil to apply force. It's like a lever to apply force, just a mechanism to apply force. If the 3 engines fail, then what will we do? Then you should why 3 engines? We have 2 engines. Usually most aircraft have 2 engines, and they are designed to operate one. It's called one engine out. That one engine is, if it's out of action, the pilot can still fly the plane with one engine. That's called one engine out. But usually for small planes, like I used to fly as well, in those emergency procedures, what they do is that if there's only one engine, and they say that if the engine fails, you have to gain height immediately with whatever power you have. And then once you are at a height, you try to glide down gradually without power, and just using the air and by the use of the control surfaces. The engines are on the wings. Engines are usually placed on the wings to make the wings a little heavy and a little stable, because they are very light. Jet engines are usually placed on the wings. And there was another question here. इससे पहले question आया था, difference in design between supersonic and subsonic. There's a lot of difference, because the air behaves very, very differently in subsonic conditions and supersonic conditions. The wing design is different. The aeroplane design is very different. As I've shown you, that's a delta wing, and the intake for the engine is different, because sometimes there is a bit of a choking of the air, and the air does not enter the engine. So there are lots of, it's a totally different world. Subsonic design and supersonic design are 2 different worlds. Or kuch? Okay, if we have 5 minutes, I'll tell you a bit about jet engines. Difference, ये तो मैंने बात कर ली. Supersonic and subsonic की. अच्छा. Jet engine is the most simple in design, but the most complex in technology, right? You really have to, because of the kind of speed and the revolution, sometimes, for small engines, they sometimes rotate at 50,000 revolutions in a minute, 100,000 revolutions in a minute, very small engines. So there's a lot of centrifugal force generated that has to be contained. And then, all the parts have to be balanced. So otherwise, it is very simple. And you take air into a compressor, you compress it to make it more combustible. Then you mix it with fuel in the combustor, then you burn the fuel, and then the hot exhaust gases move a turbine. That's the basics of a jet engine. And then the exhaust gases, when they move a turbine, the turbine is generally attached to a propeller, or it makes the exhaust gases exit through a nozzle. And when they exit at very high speed, the plane is moved forward at a very high speed. Okay, any more questions? Chat mein? What will happen if the planes are straight? What type of aeroplanes did you fly? Okay, I learned on a basic Cessna 152, then I flew the Bulldog acrobatic trainer, which is like, it flies upside down and all the acrobatic maneuvers that you see in fighter planes. I've flown a 4-seater Piper Cherokee, and I've flown a Slingsby and a biplane also. The earlier designs which had 2 wings. You've seen some of the pictures. That's what I've flown. What I'll do is I'll share a link with Aleem that there is a YouTube channel where I put some videos of some of these aviation lectures and also some videos of my flying. If you're interested, you can have a look. Okay. So are we done now?
Okay, I think, are there any further questions? If there are no further questions, then I think we'll call this session to a close. Thank you very much, Sarah. Thank you for doing this. I think it was very intuitive. And even I, who's an aeronautical engineer, I was enjoying your, your descriptions of various things. So thank you very much for doing this session.
Thank you. I'm sure we would have done better in person, and I'm sorry. I just assumed that I would be able to switch the camera to the other side and explain the plane properly.
No, that's okay.
It would have
I think
helped,
this was great.
maybe next time, inshallah.
Thank you very much for doing the session. We really appreciate it.
Okay. Thank you. I
Allah
enjoyed
Hafiz,
it
see you
as
some
well.
other time.
Allah Hafiz, and now make sure you make your plane for the assignment. Your course coordinator will give you the assignment. You have to make a cardboard plane and fly it. Okay.